Hi, this is Keith Littleton here at JTech in Jacksonville, Florida. We're going to do another Google Glass class on 3 different items. We're going to do it on a generator, a Heister forklift, and a Class A Peterbilt. So each one of them have an electrical problem. We're going to go through the basic diagnostic process and just let you look at some of the technology we have and just kind of the teaching styles that we go through to teach technicians their basic skills to be able to diagnose and fix it right the first time. So let's get started. Okay, we're working on a Trailblazer welder generator made by Miller, and this unit is having a problem with cranking. As you can see, I'm trying to start it. I don't know if you can hear that, but the starter solenoid is engaging. So what we're going to do, I've already checked the battery. Since I'm hearing the solenoid, I'm going to ignore the ignition switch at this moment. So what we're going to do is we're going to come over and I put these 2 leads across the solenoid. As you can see up here on the board, where I put that is 1 lead. All right, let's see here. We're going to do this just so I can show you. I put 1 lead right there and the other lead right there. And what that does, and I'm going to check the voltage drop across this connection right there, okay? And what we're doing, since I hear the solenoid engaging, what I want to do now is make sure that we have very little resistance coming across this connection. What we're going to do is I'm doing this by myself, so I'm going to come over and I'm going to engage the starter and then turn my meter on. Okay, there we go. We have 12.3 volts voltage drop from this connection to this connection. 12.3 volts to make it across that connection. That's how much being used across there. That's no good. We only want about 0 volts going across that. You know, we can have up to, on a starting circuit, about 500 millivolts. But since we have 12.3 coming across this connection, we can diagnose that that's a bad solenoid. Okay, now I've put the new solenoid on. Everything's hooked back up. So what we're going to do now, I've got the meter still hooked up, and I'm going to crank it over. It's going to get kind of loud, but just take a look at this meter as I'm cranking it. Okay, now as you noticed, what we had across the connection from the meter now on a good solenoid was about 20 to 30 millivolts. So that's a good connection. So it only took about 20 to 30 millivolts to come around that connection. So that's how we diagnose with using voltage drop. Okay, so now that we've diagnosed the generator starting system, we're going to move on to a Heister forklift, and the charging system has failed on it, so we're going to take a look at that now. Okay, what we're working on is a Heister forklift with a diesel Isuzu engine, and the charging system's failed on it. So what we're going to do, I've hooked the digital multimeter up to the battery, and we are going to start the forklift. Okay. So the charging system voltage right now was about the same as what battery voltage is, so charging system is not working. So what we're going to do is walk over to the board, and this is the basic wiring diagram. So we've checked it here at the battery, and we're getting like 12.2. I charged the battery beforehand, got it to like 12.5, and so it's, you know, it'd get it running. And so basically what we're going to do is we're going to check the ground circuit and check the positive circuit coming into the field exciting circuit, and you know, diagnose, is it a wiring problem or is it an alternator problem? So that's what we're going to do next. What we've got here to save on time, I have went ahead and checked the ground circuit. The ground circuit's good, and but I did find that the BAT circuit, the output circuit of the alternator, has nothing. So battery voltage on this is 12.7. So as I come right back here, I know it's a little hard for you to see, but I'm right at the back of the alternator on the output. And you can see there we've only got about maybe 40 millivolts. So I should have 12.7 volts. So we found our circuit. So we basically probably just have an open circuit. Maybe something's got disconnected. So let's go up to the board. So what I've basically got is I've got an open circuit somewhere between the battery and here. So we'll look at a more detailed wiring diagram, see if we have any fuses blown, and these types of things. But we'll get that circuit fixed, and then we'll check charging system voltage again. Okay, as you can tell, it's running. So what we're going to do now is check charging system voltage. We're going to raise the RPM just a little bit. We got 14 volts charging system voltage now that we repaired the wire going from the alternator. Okay, as you saw, I have repaired the charging system on the vehicle. So we had a break in between the battery, positive side of the battery, and the output of the alternator. So all it was there was a connector midstream actually on the harness, and it just came loose. So I just plugged it back in. So basically, we found out that we had no battery voltage at the output side of the alternator, and that's all it was. So pretty simple fix. But as you can see, understanding basic electrical, no matter what it is, forklift, generator, as you've seen already, it's just a basic understanding of how to use this test equipment and follow a diagram. So let's move on to the next on this 2009 Peterbilt. The batteries go dead after about 24 hours of this truck sitting. So first thing we're going to do is do a visual inspection, make sure nothing's been left on, make sure that the interior lights, these types of things have not been left on. So let's get inside and take a look at that. It's going to take a minute for the interior lights to go off, but I haven't touched anything. The key is out. So once these interior lights go out, I don't see anything, no dash lights. Sometimes guys will wire a radio on to where it'll draw on the battery. The Qualcomm unit has powered down. It is not on. So the interior lights are off now. Make sure nothing in the cab back here, in the sleeper. I don't see anything. And make sure this other interior light is off, and it is. So what we'll do, we will get out of the vehicle, and we'll go down and I'll show you how to do the parasitic drain test. All right, let's open the battery box. Okay, this is a 3-battery system. We got 3 12-volt batteries. Each one of these batteries is going to carry around a 30 to 50 milliamp acceptable draw. So if you times that by 3, we're looking at about 100 milliamps that this system normally could have, and it sit for 3 weeks, a couple weeks, and would not have a problem. But this vehicle sits for a day or two, and the batteries start getting low. So we definitely have a parasitic drain on this. We're going to find out what it is, and we're going to show you how to do that. So on the meter, we want to make sure to put your positive lead over here on the amps, and keep your black lead where it says the common. So we're going to turn it right down to 20 milliamps. And this is where it's going to get a little tricky. They have special service tools that you can put in here, that you can put your meter leads and go ahead and connect them, and then disconnect the battery so it puts it in series and never disconnects the battery from the system. And the reason that's important is there's computers on this system. I think this system has about 5 computers that those go to sleep when they're not being used. And if they don't go to sleep, there's an internal failure, there's a communication failure, and they stay on. That could be part of your parasitic drain. So when you go to take this off, it gets kind of tricky, but I'm going to do it here without the special service tool. Okay, I'm going to make sure I keep a little bit of pressure on this post so I can get up underneath it. I'm going to put a positive post in there and rock this up just a little bit. There. Pull it off to the side. So now I'm in series with the meter, and the meter is pulling right now 1 amp. So we've got 1 amp, and that's unacceptable right now, but we got to wait about 10 minutes, and once we do that, then we'll find out if it does fall down to an acceptable amount. So we're going to wait here about 10 minutes, and then we'll see what we got. Okay, we waited about 10 minutes and we still got the exact same draw. So we have an unacceptable parasitic drain on this, about 900 milliamps. Could be an interior light, could be something that we've missed, or something being left on that's pulling just under an amp. Because remember, you can have about 100 milliamps and it'd be acceptable. So what we're going to do now is we're going to do another visual inspection to make sure we haven't missed something. And then if we don't see anything, then we'll start pulling fuses one at a time, observing the meter, and find out when the meter goes down to an acceptable amount. And then we found our circuit, and then we diagnose it from there. Okay, what we found, the glove box light was staying on, and as you can see on the meter, we're showing about 120 milliamps, which is acceptable. So we fixed the glove box light. What it was, the door screws had came loose from vibration, and the door sagged away from the switch. So we tightened everything, put it back on, and the light's working fine. So that's how you diagnose a parasitic drain. Some are harder than that, but this one turned out being a pretty simple one. And so hope that was helpful, and we'll go ahead and put this thing back together. Okay, we're done. We've done all three exercises. We've diagnosed a generator, we diagnosed the forklift, and we diagnosed a Class A truck. These fundamental diagnostics that we demonstrated are things that technicians overlook every day, just either because they're getting in a hurry or they haven't been trained properly. So here at J-Tech, that's what we mean to do, is make sure to train the guys so they completely understand what they're doing and fix it right the first time. Thanks.